Good afternoon, everybody. So when an SME starts out in business and brings a new innovation to the market, it's challenging. It's challenging on a number of fronts because you're doing something different. We don't do that. Never done it like that before. We do this. So the first object you've got to overcome are changing hearts and minds before you even start to even get the concepts going. So it's essential that you surround yourself with the right people. I have a non-exec director, Paul Withers, of some might know, of HBPW Consulting, risk accredited consultancy in Retford. And Paul is 40 years a chartered civil engineer. So straight away, any projects that come through to us, we will assess what those projects are and make sure and look at how we can value engineer with a potential new product that is going to change things. On a day-to-day basis, Patrick O'Neill, my technical director, has helped unlock what I'm about to show you. So what is the cause of all this? Climate change. We've heard about it all morning. And the three key elements that I picked up on this morning was surface water, SUDS, sustainable urban drainage systems, and attenuation. And invariably, when we look at the track and we look at all sorts of, not just the track, but off track, is how do we divert water? How do we move water around that typically, in a lot of instances, you've got very narrow entry points. You can't always get a pipe in there. Pipes aren't always the answer to everything. And they can be very rigid in what they do. So, as we see more frequent flooding, heavier storms. And when you look at that, and I saw some of the pictures before that were shown up, the water can't get through the ballast. The ballast is silted up, stuck. Won't let that water through. So how do we release that water? Because there might even be good drainage systems in there, but it's just not getting to it. Ta-da! TDS 400. I never travel anywhere without it. Especially when I was coming to York today, I thought it's bound to be flooding in York, so at least if anything happens, I can attach it to the feet of my soles and walk over with drainage flowing on the subbase, which is an apt point, because that is exactly what it's about. It's about letting water, keeps an open pore, keeps that open void. So that's going nowhere. Okay, and you can put 1, 2, 3, 4, however many you need, and they with the K values and all the hydraulic information that can be is all there to support it. So the water will literally, through hydraulic pressure, be forced through the panels and it meanders through. People go, doesn't it silt up? Well, the good news is no, it doesn't. We've worked with academics. The Tuffley case study, which Mark is going to explain shortly, has been in nearly 5 years, and it is proven. This is just in the rail industry. I've been working within polymeric waste for over 20 years, and in the early prototype stuff, I've got stuff in the Olympic Park that's working as good today as the day it was put in. So some of those questions, well, we don't want to be first. Well, the good news is you're not. It's most important that we build on what we've done, and we do have good evidence. We're PADS approved, which is great, and that took some doing. I haven't got my good looks for nothing. Tenacity and working at people and working around the network. We've done presentations after presentation. Many people in this room will have seen my face before because they never forget it. But it's also really important that we look at how we work within the engineering standards. And it is absolutely about taking into consideration the existing drainage systems are there. We are not about just saying that comes out and ours goes in. It's about, how do we work with it? So in the examples where the water's flooding the track, you could insert TDS 400 in there and get the water to under the drainage system without ripping everything out. We can reduce trench sizes. 600 trench comes down to 300 trench. You think about that just in terms of excavation. It's immense. You're not having to use as much ballast. Ballast is massive on CO2. We've basically a paradigm shift the other way because we're getting rid of what would normally be very difficult plastics that would go to landfill. So when children turn around and say, what are you doing in your daily activity about climate change? Well, I'm turning it into drainage. I'm doing it. This is live. This is happening today. Okay? It's really important that we see this action to impact on climate change. The recycled polymeric content, 95% recycled content, all UK sourced, which is even better still. It keeps this open environment and it's all recyclable. And when you look at traditional excavation versus TDS 400 excavation, just in that 600 mil being reduced down to 300 mil, the tons of rail ballast excavated goes from 315 to 155. That's just excavation on that one bit. When you start scaling these numbers up, the 112 tons of CO2e reduction per kilometre of drainage just because of reduced excavation. Massive impact. So if we look at the rail landscape, the important thing to us is how it's all connected up. We've got the drainage connectivity and the network resilience. And we basically split it into 4 key areas: the land boundaries and earthworks, the rail assets and structures, track and trackside, and track bed and formation. And very simply, I think crest, flumes, toe, 4 foot, 6 foot, 10 foot, wing walls, back of wall drainage. Why does several vehicles have to turn up on site with blocks and then drainage pipes and then shingle and then the land? How about putting the product stuck at source onto the back of wall drainage, just add land when vehicle turns up? There are ways to mitigate carbon. There are ways of doing things differently and potentially smarter. So we cover many applications right across the network. And but it's absolutely critical that you look at it as a whole. I'm not everything to everyone. TDS 400 is not everything to everyone. It is part of a new tool that you can put in your drainage toolbox and say, how about this? Because it might just add value to what we're doing, or it might actually just put some resilience into the network. It might actually bypass a failed drain without having to rip it all out. There are different ways it can be used. It can be applied in all sorts of very successful interventions. So 3 sort of interesting points here. So the one on the far right there was crew, and the reason the panels are laid flat is that there were metal stanchions there and they couldn't get drainage through them. So what are we going to do for drainage? I said, well, lay TDS 400 flat. Because joking aside, but if I put that on the floor, the water's still going to go underneath it. It's going to travel through it. And actually right now it's solved a problem that they had in the area of the drainage. I was speaking with the guys that put it in the other week. They said it's actually solved that problem. So they said, we're really grateful. He's now come back onto me again. Pill tunnel in the middle, that had big issues with contamination into local farmers' lakes. And by front loading and acting as a filter, we took a lot of the red oxide out. And so it's now clear. I mean, when we saw the bottles, they're absolutely crystal clear. The guys rang me up and said, I'd like to drink it, Carl. I can't, but I said I would like to drink it, which is really good. And then these Central Rail System Alliance. Oh, sorry, that was crew. Allstoke Sidings is the other one. That's still an ongoing project. We put in a 40-metre stretch down there, which I think is on that slide there. And that was actually to look at lowering the water table. so a high flood area. So by getting the water down, so basically putting the product on its tip end to get the water to lower, and that's still being monitored right now. So in terms of cost-benefit analysis, 30% cost savings on against traditional methods. If you used a ballast vac, it can be up to 50%. So depending on the methodology of what you install, can really make quite a big impact in terms of the overall budget. So without further ado, I'll pass you over to Mark in 1 second, but just on the 650 metre stretch at Tuffley, which Mark's about to tell you about, if you actually extrapolated that out, 33 shift cycle would come down to 7 shifts using TDS 400. And we noticed at the speed of excavation, it literally goes in at the speed of excavation. So it was really significant in terms of how it can really take a lot of cost. And more importantly, better utilisation of resource. I'll skip past that because I'm conscious of time. I'm going to pass you over to Mark, who's going to explain about the Tuffley install, and then I'll just come back and finish at the end. Thank you.
So thank you, Carl. For those who don't know me, Mark Howells, I'm the Senior Asset Engineer for Drainage and Lineside on Western Route. I'm going to talk to you for a couple of minutes about an application of TDS 400. So, as Carl said, it's not the solution for everything. This particular site is near Gloucester, so it's on the Bristol to Gloucester main line. Now 4.5 years ago, nearly 5 years ago, we instigated this work. A failed drainage system that needed to be remedied. We needed to find a drainage solution to raise the line speed. And again, I'm aware that we haven't got a lot of time, so I'll skip through some of the details. These are all on the slides, which I know will be sent out afterwards. So just thinking about kind of the existing drainage system, we had a drainage system in the 6 foot between 2 lines. This is a very idealised cross-section. I didn't have time to whip up a section for Tuffley, but this gives you the kind of concept idea that there are 3 layers of TDS 400 on their side, far on the right-hand side there, and a layer of TDS 400 laid on its side. So the drainage assets are in the middle. The concrete pipe protection blocks are there. In terms of photographs, not me that took the photographs on the night. I wasn't able to get there, but Sysrail helped Civils Water Management to install this. You can just about see on the bottom right of the picture that there are concrete pipe protection blocks. Now those are protecting the clay pipe that's already in the ground. Nothing particularly wrong with the clay pipe from the CCTV survey that we did, but water couldn't get to the drain. So that's where this product came in, and we were able to get water back into the drainage system. You can see there the machine just taken off the ballast. Again, it could be delivered by hand. It doesn't need to be delivered by machine. Again, really good shots here of just that TDS 400 going in on its side, and then the panel laid laterally. So that's encouraging water to get from the formation into the drainage system, which is the concept here, is the idea. In terms of just some of the site conditions, this was pre-work 2017, so it's been a long-standing issue, always been failed formation, very cohesive material, lots of clay fines. You can see that would clearly cause cyclic top. There's cant issues with cant being all over the place. That's the pre-work. Now, here's one I made earlier in true Blue Peter fashion, so you can kind of see an exaggerated cross-section there. Bottom left-hand side, water was collecting at the bottom of the formation. So having that TDS 400 really helped to get water out of the formation and into the drain. And really important to stress that it's got to be considered as part of the drainage system. So this is just a small element of the bigger drainage system. Assets in ellipse, for example, when we went back recently, double checking the asset condition, doing condition scripts in ellipse, it's all part of the system. So you can see there, that's what we had. This is the site visit that I referred to just a moment ago, very recent with Carl. Unfortunately, we didn't get the line blockage that we requested, but we did manage to get to the side of the track. So you can see same site, same position, same sleepers, same components, definitely different ballast. We've dug the ballast out, so the local P-Way team helped us dig out the ballast post the work. And since that time, 2019, we've seen no deterioration in the track. We've basically seen that actually doing this TDS 400 trial and getting water into that existing drainage system has helped to resolve the issue here. Now, as Carl said, it's not for everywhere. It doesn't solve every issue, but I genuinely see it as an opportunity to help us where we don't want to just rip out the existing system. Think about the embodied carbon that we would have had if we'd have ripped this system out. By not ripping it out, we've saved a lot. That's kind of the summary of where we are. Track quality hasn't deteriorated. Hopefully, we will see in the future that we can deploy this technology and this product more widely. But basically, it's trying to get away from the fact that actually, although we've reduced, as Mohammed said in his presentation, the rate of degradation, there will always be a need for maintenance, there'll always be a need for inspection, but it's just trying to get the water into the drainage system, and it can help solve some of the issues. So I think, without further ado, I'm going to pass back to Carl, and thank you very much.
So thank you, Mark. That's so really when you are bringing a new product to market and you can get into a trial like that, and just short of 5 years, we've really made an impact with what was a challenging wet bed without it being dug out. Is really quite satisfying. This is the key point. It passively releases large volumes of water. So it's not waiting for a 100-year storm. It's doing it all the time, 365 days a year, 24/7. It's just moving that volume. It keeps those crucial pathways open, and it's constantly releasing that water, unlike a pipe, which doesn't. We are passionate. You probably sense that by me. I'm very passionate about the environment. I'm passionate about drainage. God knows why, but I am. Whoever thought I'd end up in drainage, I've no idea. But, we're passionate about the decarbonisation piece and helping the climate. If I'm looking for a legacy, my legacy is my children, my children's children, and their children's children, that they actually do have a future, that we are putting things in place now in our generation to make sure that their generations have got a chance. Because when you look at some of the 1.5–2% water potential rises, it's massive. It's a massive problem. And there's still many people who haven't woken up to it yet. We notice it more because we're in the world of drainage. But it's a really, really serious issue. We do work a lot with academia. We've got some great professors around us that have been advising us, and indeed more professors are working with us at the moment on different testings that we're doing all the time to constantly enhance and bring any findings into our spec, into making it aware to people so that we can get best value out of it. And in the words of Thomas Telford, drainage, drainage, and more drainage. Thank you very much.